Hey guys, welcome back to my channel. Today we'll solve the March 12th daily lead code problem. It's a medium problem. Let's see the question. The question is to remove zero sum consecutive nodes from the linked list. So given head of the linked list, we repeatedly delete consecutive sequence of nodes that sum up to zero. After doing so, return head of the final linked list. You may return any such answer. Yeah, multiple answers can be possible. Say like here, 1, 2, 3 is there, which sums up to 0. So we could return 3 comma 1, or we could return 1 2 comma 1, or like that. Okay, it makes sense. And constraints are maximum we have only 1000 nodes. Okay. Hmm. So mostly in such problems where the head of the node also might be deleted. See here, one is also there is a possibility that the head of the node can be deleted. So in such cases, it's always good to create. Good, I mean, the sense it's very easy to create a king node. In, uh, let's declare a new node, and initially let's have the value 0, and its next value will be head. So this king node is pointing to this head node. Okay. Now what we do is see like if we have 1 comma 2 comma, let's take this example and analyze it. When we have 1 comma 2 comma minus 3 comma 3 comma 1, now we have added a head pointer also, so it will be like this. What we'll do is just like to some problem, which is a very standard problem on Leetcode, we'll have a map to remember the current sum. So let's do a prefix sum here. Here it will be 1 3 0 here, 3 here, and 4 here. So these elements will create a map. So how in the sense in the first step in the map it is empty. In the second step 0 is pointed to the uh, let's say first node. In the second step 0 is pointing to first node and 1 is pointing to second node. In the third step similarly, and 3 is pointing to third node. And now we get 0, right? Now what we'll do is we'll remove this 0 to fourth node. The rest will remain same. And now we get 4 also. Now along with this we'll add 4 as fifth node. So these values will be there in the map. Now what we'll do is we will again uh, iterate through the list from the beginning, right? Now what we do is again we calculate this pre-sum. Now I see 0 here. I will check in the map what is the value 0 is holding. If it's holding same value as the node I am currently, I won't do anything. Okay, but here the sum is 0 and it is pointing to fourth node. So what that means? What it means is from this 0 sum up to the fourth node, the entire sum is equal to 0. Do you get it? Like, see, what, how the sum becomes equal in future to the current value, because the set of elements in between these two nodes, when we sum it, it's getting the sum is equal to 0. That's why the value is same, right? Otherwise, there will be an increment or decrement. See, here 1 is there, 2 is, take this node, here 1 is there, 2 is there, and minus 3 is there. Just because of summing these three nodes, uh, we are getting the sum same as this earlier sum. If it was something else, this sum won't be equal. Only if the sum of the elements from this current node till this last node, if they are 0, then only the prefix sum will be equal, right? Similarly, you take this two, the two values are same only because this sum is 0, right? So now what we'll do is we'll iterate to the array, and what we'll do from this current node, we will make its next as farthest farthest node with same sum, that one's next. So in this, what we'll do is in the second iteration, we will make first node next as fourth node next, which is equal to fifth node. Also, uh, second, yeah, third node next as 1, 2, 3, 4, 5. So third node's next as fifth node next, which is equal to sixth node. So basically, uh, after doing this first operation, technically from 0, it will point to 3 and 4, right? So after this, the list would be 0, 3, and 4. Since we will start from the head only, this second operation makes no change because we will lose the third node in first operation itself. Because after first node, we are directly going to fifth node. So this third node, even we change its pointing to this, from this to this fourth node, it won't make any difference, right? So like this, when we do, basically what we are doing is we are taking this current node, we are checking whether its sum has already been seen. If it's seen, we will make that value equal to the farthest node with same sums next, because the sum in between them will add up to 0. See, here 0 is there, here 0 is there, and sum in between them 1, 2, 3. make 0. So we will point this 0 to the next of this node, which is 3. So 0 will point to 3 and 3 will point to 4, and that will be our list. Though there is in this while loop, if we change this 3 to point to this 4 also, that is also valid. But since we have changed this to point this, there will be no case where we traverse to this node at all. So our final this will be this. And since they have said you may return any such answer, our logic works. I hope this makes sense. I suggest trying more examples. Let's also take another example if you want to be more comfortable. Uh, this one this one is not much complicated. Let's take even some more complicated one. 3 is there, then this adds to 6, then this 3, then this adds to 1. Let's take I will give my own example. Take this case. There was 1, there was 2, there was minus 2, there was 4, there was minus 4, there was 5, there was 1, uh, there was minus 5, and there was uh, let's say 2, right? Mm. So now, just like the earlier step, we'll add a 0 in front, the king node, right? Now what we do is, let's calculate prefix sum. First it's 0, 1, 3, sorry, 3, and 1 again, 5, 1 again, 6, 2, 2, let this be 1, and 3. Okay. Now in the first operation, uh, after the final, like after doing this, all this, these nodes will be the major nodes hold. We will take the farthest node holding the value, right? So this 3 is there, this 2 is there. I have I calculated right? Yeah, this should be 8 plus 1, 6, 6 plus 1, I'm sorry, 7, and yeah, 2, right? So this 7 also will be there. This is the farthest, this 6 is the farthest, and for 1, this is the farthest, and for 0, there is this. So these nodes won't be there. I mean, the farthest node having the same value will be stored in the map, right? So we have this. Now what we do, we reiterate and recalculate the sum. So 0 is there. 0 is, I'm at first node, and the 0 is pointing to this node itself. So I won't do anything. So this 0 be as such. Now I came to 1. The farthest I have seen this 1 is here. So I will remap this 1 to next of this one, which is 5. So if I do this operation, I would end up like this. Uh, After this, the change would be like this. 5 after like 1 means after the 1 in the farthest node. So I will put these values, right? I will put these values, and so the list will become like this. even though we iterate and we see 3 and we'll point this 3 to this 3. But what happens here? I have already pointed this one to this 5, so this 3 won't be there at all. So let's we won't go there at all, right? So this is how it happens. After doing this operation, we'll have this list, and in here there is no consecutive sum of 0, right? 1 plus 5 is not 0. No consecutive sequence is 0. Yeah, that's how we arrive it here. Say we had a minus 1 here for a change, right? Now what happens? This 2 will be there, and this 1 will here 1 will be there. The farthest node won't be this one, it would be this one, and here 3 also will be a farthest node. And this one will directly point to the next of this, which is null. So the entire list will shrink to this one. Why is this? Because see the sum here. Minus 4 plus minus 2 plus 4, 2. 2 minus 4 is minus 2, and minus 2 plus 5 is 3. 3 plus 1 is 4, and 4 minus 5 is minus 2, and all this adds to 0. That's the reason, right? I mean, all this adds to 0. So that's the reason uh, we have 0 comma 1. So remembering the farthest node having the same prefix sum and remapping the node. That's the thing we are going to do, right? Let's try to code it. Yeah. Now it feels very pretty simple. Uh, let's create an unordered map. The key value would be list node star sum, and the value sum int is enough. And let's create a pointer to the king node, right? Now if while 10, so we'll iterate. First we will remember the farthest node. So just we will do m of sum equal to 10. So this will keep saving only the farthest node, right? First it will save here 1, but when it comes finally here, this one would be saved. This one's node, right? Like that. Now after doing this, what I will do is, yeah, I have to iterate 10. Now again, remap temp to king. Again make sum 0. Again while temp sum plus equal to temp val if m dot find of sum, no, yeah, sum would be there. So if m of sum is not equal to temp, so it is pointing to some other value in the farther. What we will do, temp next equal to the next of that node. So we will forget all the nodes in between because their sum would be 0. Otherwise, the sum won't be same, right? That bit uh, subarray sum should be 0. Otherwise, this prefix sum won't become equal from its pass to this, right? So we'll do this and we'll go temp equal to temp next. And after doing this operation, we will return king nodes next. Yeah, I got that. It works. Let's try to submit it. Time complexity is big O of n. Yeah, it works. Since constraint is only 1000, no need to worry why we are getting very small slow. But this is the most optimal process we can do, right? So this is how you solve it. In case you don't get this idea of this forgetting the array in between based on prefix sum, solve the two sum problem, three sum problem, then also try more examples and think why like we are pointing this next variable to the farthest node's next variable. Be, uh, we are doing that basically because this sum, subarray sum is 0. That's why the prefix sum from here 1, it again comes to 1 because there should be no increment or decrement, right? Then only we'll have this prefix sum to be 1 when the subarray in between them adds up to 0. Then we point it to the next variable of that node so that we skip all these nodes because they add to 0, and our condition is to remove all the sequences which add consecutive sequences which add up to 0. So that's how you solve it and that's how you get it. Thank you. I hope this makes sense, and let's see in another question. Thank you.